Okay, here's one for this morning. So, assuming I, I'm some big galactic overlord type entity, right? And I capture planets with a big shrink wrap bag, right? And so I put my shrink ball over the Earth or whatever planet I'm trying to capture, right? And I suck all of the air out of it. Now I bring this up because you don't want to. I don't know what these are actually. I think they're junipers. No, they're cypress. They're cypress. Um, these are kind of shrink wrapping spider webs. It's kind of terrifying. Very terrifying. Especially to have seen them in the middle of the night. But so what I was wondering was what the metric would be, assuming you covered the surface of the Earth, right? And you sucked out all of the air from it. Now, in terms of geometry and topology, you would essentially be fuzzing out the surface of your planet by some radius of curvature, and you're sort of approximating these peaks and points with this figure. Now, I say this because if we define this a little bit more mathematically, right, in a way it almost feels like the way the fractals render, right? If you're rendering them from if you look at the Mandelbrot, the way that it renders, right, it kind of carves out more and more of the shape. But you're start with this initial volume of the sphere. Let's say that it's M, right? And then you have the volume of the surface, right, which is N. And as you're vacuuming this the air out of the surface, right, using some sort of metric, right, whether we need to use air pressure or volume or what, however you want to measure it, right, you sort of define a way for the air to get sucked out of it and measure relative volumes. Now, I don't know why I bring this up, but the too many spiders thing over there, it makes me think about how that tree just looks vacuum sealed in a thin film. And I wonder, and I think this is a form of a hyperbolic plane geometry. Not 100% sure. Honestly, high school me would know more about this than I would right now, but it makes me think about these structures, right, where you have these large spires and there's a sheet that covers it, and essentially it's kind of like now we're getting into graph theory, right? the points are fixed. There's fixed vertices, and you have edges between the vertices. But just being instead of just being planar, you have these branes, right? These membranes that have topological properties and that they can stretch and deform and whatnot, but the logical connections between each sheet remain connected. And now if you visualize that with whatever you put on the our sheet geometry, the way these deform. I'm sorry, I've just been going through quite a bit of an existential crisis quite recently. I mean, there's a reason why I try to get everything on camera, but now I'm trying to talk to the world like I used to. Don't know why I didn't put these ideas out here earlier, but well, you got the some sort of notion of Euler characteristic of graphs and having surfaces and surfaces meshes. Well, honestly, it's getting hard to start thinking of prompts on the walks. I might start doing more cleaning, or I've been digging through my old stuff, but that was some geometry stuff.